Hi class, and welcome to lesson 1.1. I'm sorry I didn't start right at the first page. Okay, taking a look here. Today we're going to look at what's called exact values of angles as well as angles in standard position. Okay, so let's go take a look at some of the basics. And some of this stuff may be new. So again, wherever you see something that's boxed or starred or underlined, those are key points that I want you to remember from the lesson. So let's go back to some basics here. There are two specific special triangles that have exact side lengths that need to be learned. Okay, this is probably new for you. Okay, these are called special trig triangles. And the angles for these range either 30 degrees, 45 degrees, or 60 degrees. These triangles are called two different things. This is what I call the 1, 1 root 2 triangle. And the second one is the 1, 2 root 3 triangle. Again, you might call this one the 45 degree angle. You may see it expressed that way. And you may say this as the 30-60 degree triangle. So there may have a couple names on it, but all the information is the same regardless of how you identify it. Just remember, folks, that when you're doing exact values, initially you're just going to be using the ratios on these triangles, but if you're doing some other calculations, then make sure your calculator is in degree mode. Quite often it can slip out of degree mode. So what we're going to do, folks, is these are two special triangles you will have to memorize. So if you remember the names, 1, 1 root 2, okay, just think 1, 1's the same, so that means that both your adjacent and your opposite sides are going to be equal. And using Pythagorean theorem, add those two up and square them and find the square root. Your hypotenuse is your square root. The other one is the 1, 2 root 3. And how I always remember this is that the 2 is the bigger side, so it's got to be the hypotenuse. And I always make root 3 be beside the 30-degree angle. All right, so the 30 and the root 3 kind of stick together. All right, so that's how I remember special triangles. You may develop a different method, and that's fine. All right, let's take a look at some of these examples here. Now, in particular, I want you to pay attention how the question's asked. If it says to state the exact values, then 9 times out of 10 you're not using your calculator. You're going to use these special triangles, either your 1, 1 root 2 or your 1, 2 root 3 triangle. All right, so cos of 30 degrees. So first of all, if you go to your special triangle here, and 30 degrees is right here. I'm just going to change color so you can see. So 30 degrees is right here, ladies and gentlemen. And what we're going to be doing with that is, remember, cos is what relationship? So cos theta, if you use your SOHCAHTOA, that is the adjacent side over your hypotenuse side. Okay, now we're going to sub in the angle. So cos of 30 degrees equals, what's my adjacent side from there? It's 1, and your hypotenuse is 2. Okay, I apologize. I have to back that up, folks. My fault. So back that up for a second. I just read it wrong. The adjacent side, ladies and gentlemen, is root 3. My fault. Divided by the hypotenuse, which is 2. So the exact value for the cos of 30 equals root 3 over 2. Again, my apologizing for getting the adjacent side wrong. Okay? All right, next one, tan of 60 degrees. So again, we're going to look at the 60-degree angle. And remember what tan is. So tan theta is the opposite over the adjacent. So based on that angle of reference, let's sub in that angle. So tan of 60 degrees, the opposite side going across is root 3 over my adjacent side, which is 1. So tan of 60 degrees just equals root 3. And the third example we're going to take a look at is sine of 45. So again, we're on the other triangle now. Doesn't really matter which angle you use for reference because they're both going to be equivalent. both of them have the same opposite and adjacent values. But just remember, sine theta is the opposite over the hypotenuse. So sub in your angle, sine of 45 degrees equals the opposite side, which is 1, over the hypotenuse side, which is root 2. So again, those are exact values when you use your special triangles. Okay? Any questions at that? Please come and see me in class. On to the next part. So what we're going to investigate now is quadrants and when your trig ratios within a grid system are positive or negative. So just remember, guys, that when we do quadrants, this is Q1, this is Q2, you go counterclockwise, this is Q3, this is Q4. And how do we use that to help us? We use it based on the cast rule. Okay, this is something you're going to want to memorize. Make sure you know this for sure. You'll be using this a lot. Okay, the cast rule tells us when each of the ratios, trig ratios, are positive. So if we start with Q1 in quadrant 1, and that's the one that you're most familiar with, guys. We spend most of your mathematics in quadrant 1. Okay, that's why, because all of the trigonometric ratios, sine, cos, and tan, are all positive. Okay, if we have an angle in quadrant 2, the only one that is positive in that case is the sine ratio. So all the others are going to be negative. Likewise, in quadrant 3, the tangent ratio is the only one that's going to be positive. So the other sine and cosine are negative. And Q4 is where cosine is positive and all the others are negative. So hopefully you can deduce from this that each trig ratio has 2 spots where it is positive. So for example, the sine, so sine theta would be positive in quadrants 1 and quadrant 2. The cosine the cos theta, or an angle of cosine, is going to be positive in Q1 and Q4, whereas the tangent of any angle in the quadrant system is going to be positive in Q1 and Q3. So sometimes that leads to multiple answers because it can be positive in more than one quadrant. All right, let's do an example here to help you clarify that. Okay, so basically if you're on a test, folks, as soon as you get a test paper, just simply go like this. And you may have to do that several times with a question, do the cast rule, okay? All right, here we go. Let's take a look, folks. If we have the sine of 190, okay, let's just think about our degrees, for example. If we start here, that's 0 degrees. This is 180. So where is the sine of 190? Okay. Let me just pause for 1 second. Sorry about that, I'm back. Okay, so let's take a look, guys. If we know our XY grid, and remember we're going to be going this way, all right, what we're going to do is realize that the sine of 190, so if you go in quadrant 1 up to here, that includes 90 degrees. If you go past quadrant 2, that's 180 degrees. So we're actually looking at an angle here. We're going to learn about that on the next page, that this is 190 degrees in rotation. Okay, so it's more than halfway. Halfway is 180. Okay, so looking in this, what quadrant is this in? This is actually in Q3. And look at Q3, is sine positive or negative in there? And it is actually negative. So the sine is negative in Q3. Okay. All right. Taking a look at the next one, cos of 120. So again, if we start here at X and we rotate around, here's 180. So it's between 90 degrees and 120. So it's in here, guys. So the angle created is 120 degrees, like that. And that, where it ends appears in quadrant 2. And in quadrant 2 is the cosine positive or negative, and cos theta in quad 2 is negative. Okay? All right, let's take a look at the third one. Okay? The tangent of 210 degrees. So again, we go over past 180, down here to kind of like 210. So that's my angle of 210 degrees rotating. Okay, and what quadrant are we in? We're in Q3. Looking up, is Q3 tangent positive? Yes, so tangent of the angle is positive in quadrant 3. So, therefore, tan of 210 is positive. Okay, and it might be easier to go back here and summarize these, that the sine of 190 degrees is negative, and the cosine of 120 degrees is negative. Okay, so the CAST rule helps us decide if things are positive or negative depending on what quadrant they are in. And again, we're going to use this CAST rule. Now in the next page, folks, we're going to explain about these angles in standard position. That'll help you get an understanding to, hey, Mrs. R, how did I draw these angles in the first place, okay? So let's go to the angles and their standard position. All right, so an angle in standard position is the angle formed between the initial arm, okay, which is right here. That's where we start, and that's basically like 0 degrees, okay, on the x-axis, and the terminal arm, okay, as it rotates about the origin. And when we rotate in a positive direction, we go counterclockwise. Is normal rotation. All right. Okay. For any rotational angle, the reference angle is the acute angle between the terminal arm and the x-axis. So in this case, when we're only dealing in quadrant 1, our reference angle will equal our initial angle set out. Okay? All right, so the reference angle, guys, is the angle created from the x-axis to the terminal arm. All right. Now where it gets a little more confusing is in the second example. It says, what is the reference angle for 120 degrees? So again, you start at your initial arm, which is 0 degrees, right here at the x-axis, and we're going to rotate it 120 degrees. So my original angle is 120 degrees. But what you need to notice, guys, is it's 120 degrees. That's no longer an acute angle, and it doesn't match up with the x-axis. What we need to make sure we realize is the reference angle is the angle between the reference arm and the x-axis. Okay? So basically, the reference angle now becomes this value. Okay, so what do we know? Between the x-axis on the positive side and the negative side, it's 180 degrees. So to calculate your reference angle for angles that are not, that are greater than 90 but less than 180, you take 180 degrees, which is your total, and you subtract the initial angle given, which is 120 degrees. So basically the reference angle here, folks, is 60 degrees. So in this case, it's 60 degrees. Okay? All right. Second part says, what is the exact value, and remember, that's a special word, exact value, for cos of 120 degrees. So again, if you want to just simplify with your CAST rule here, okay, where's my angle going to go? 120 degrees is going to go this way. Okay, and my reference angle, ladies and gentlemen, is the what? 60 degrees. So what we need to do is just to remember, hey folks, 60 degrees is part of one of my special triangles. So if I could go like this, we know 60, we know it's 30, we know that it's going to be 1 root 3 and 2. So then we need to do the exact value, okay? Everybody ready for this? Okay, so cos of 120 degrees. Let me move it down here so you can see. Equals, take it to the reference angle, which is the cosine of 60 degrees. Okay, because in fact, they are at the same spot here, right? That's why they can equal. And then what do we know about cos of 60? Okay, the cos of 60 is the adjacent side, which is 1, over the hypotenuse, which is 2. The second thing you got to take a look at is the cast rule. Is cosine positive in that quadrant? It is not, so that's why it is negative 1 over 2. Okay, so let me just go over that again. The exact value tells you using special triangles. So again, we look at the adjacent side and the hypotenuse. So that gives us the 1/2. But then we have to double check if it's positive or negative. So again, we look at where our terminal arm lies. For cosine, the only one that's positive in that is the sine. Oh boy, I'm sorry guys. I wrote my cast down wrong. Sorry. Don't know why I did that. Sorry. Okay. That's probably what's confusing people there. Okay. Let's fix that. Sorry. Okay, I'm getting used to this video recording and I'm worried about it. So apologize for that, guys. Okay, so again, in the cast rule, when we look at quadrant 2, the sine is the only thing that's positive. So that's why cosine is negative. Again, sorry about that. Okay? All right. Any questions with that, folks, please come and see me. The other thing I want to make sure you realize, guys, is say you're given cos of maybe 320 degrees. Again, let's set cast up properly this time, okay? So make sure that you start with C at the bottom here. So C-A-S-T, okay? And 320 degrees. Again, you start at your initial arm. That's 90, that's 180, this is 270, right? So we know it's somewhere in here. So that's 320 degrees. Okay, so what would our reference angle be? And this time we need to figure out this reference angle. So again, hopefully you see the connection here. You take 360 degrees and you subtract 320 degrees, which equals which equals 40 degrees. Okay, so basically cos of 320 equals cos of 40 degrees, and then you plug that in your calculator because it's not a special triangle, so you're not getting exact values here. So you go cosine of 40 degrees equals 0.766, okay? And then you've got to check to see if it's positive or negative. And it's in quadrant 4, and cosine is positive, so your answer is positive. Let's try one more. How about let's change it up and do the sine. So let's do the sine of 220 degrees. Okay, again, set up your cast rule here, or your cast values. Then again, start at your initial arm, which is right here. And we're going to make an angle counterclockwise 220 degrees, which goes there. Okay. So it's 220 degrees. Now, let's find out how do we get our reference angle, which is just this amount. Okay. Well, hopefully you can see that we know halfway through to here is 180. So if you take 220 and subtract 180 degrees, that's going to give you, let me plug it in the calculator, or just say 40 degrees. Okay, so the sine of 40 degrees, is 40 degrees a special triangle? Nope. So plug it in your calculator. So go sine of 40. You're going to get 0.643 rounded. And then you have to decide, hey, in this quadrant, is sine positive or negative? It is negative. So you get negative value. Okay? All right. Any questions there? And again, folks, if you just plugged in your calculator, sine of 220 degrees, you would actually get that you have negative 0.643. All right? So again, just working on your cast rule, what quadrant you draw that in, and how to get your reference angle are going to be important things. Here's your homework, ladies and gentlemen. Page 2 and 3, numbers 2, 3, 5, 6, 16, and 18. Have a great day.